This is the Epsilon Zero, a brand new gaming console focused on electronics and educational entertainment. Before we take a look at its unique features, let's hear from all our team members.
Hi, I'm Advaith, the analyst lead. I manage costs and equipment. I helped with the initial drafts of the code and reviewing scripts.
I'm Fahmi. I'm the researcher. I created the game ideas, I contributed to the code, and I crafted the demonstration script.
Hi, I'm Alfie. I'm the project hardware lead. I also helped write and edit the initial project and contributed to the initial report ideas.
Hi, I'm Tushar. I worked as the design lead for the Epsilon Zero project. I worked on the PCB design, the enclosure in CAD, and I made the brand identity for the company.
Hi, I'm Koshin. I'm the project manager. I took over the development of the project and I assisted with the hardware.
The goal of the project was to develop a low-cost, handheld gaming console focused on introducing electronics to school children. We had to use limited components, such as an LCD 1602 screen, to achieve the low cost. This required creative solutions throughout the development process.
Lastly, our gaming system features a series of innovative games that are tailored for our 2-line LCD screen.
We decided to theme these games around electronics, keeping children interested and involved with its concepts. The games we developed are called Quiz Duels and Electron Race. Let's look at Electron Race first.
The player, represented by an electron, is placed on the left side of the screen. They have to then dodge the oncoming obstacles, which are depicted as areas of resistance, for as long as possible. Their score will increase each time they dodge. The speed increases with time, making the game harder. If they collide with an obstacle, the game will end, and their score will be shown in the form of a current. This game tests the player's reflexes, precision, and endurance as they aim for a high score. Let's now look at Quiz Duels.
In Quiz Duels, we've developed a competitive turn-based game that challenges players' knowledge in electronics. When the game starts, the players decide which order they will play in. Then player 1 is given a question and is presented with 4 answer options. They can choose their answer using the buttons. If they are correct, the screen will change to a car race, where their car will progress forward. They will then be told to switch to player 2. Player 2 can answer the question in the same way. If they get it wrong, their car will not move. The game will keep continuing until the finish line is reached. Whoever reaches it first is the winner of the game. This game is a unique combination of entertainment and education. As you compete with friends, you'll also deepen your knowledge of electronics.
These games were developed using C++ and the Embed library. Each game was coded with the limitations of the physical components in mind. Since the LCD class didn't permit externally defined custom characters, I had to create a public method that would allow for this functionality. We have also included a programming guide to accompany our console. This allows students to independently explore and maximize the capabilities of their devices by changing several parameters for the games.
Developing Quiz Duels and Electron Chase presented unique challenges in PCB and case design.
We used a Nucleo microcontroller from STM Electronics to store the code and control the components. It sends signals to the LCD1602 module, which allows for 2 lines of 16 characters.
To maintain a compact and ergonomic design, we opted for a custom manufactured PCB rather than a traditional breadboard.
Initially, we created a prototype for the system using a breadboard. We turned this wiring into a circuit schematic, which could then be used to generate a PCB design. Careful consideration was given to ensuring the layout would match our original concept for the device.
After the PCB's manufacture, precise soldering was required to secure all the connections. While there were several challenges faced in the process, the end result retains all of the original functionality. The final PCB sits on top of the microcontroller and is supported by a custom enclosure.
I designed the enclosure using Fusion 360. This involved making custom buttons and mounting for all the components.
The case features a removable front plate, achieved using snap fits. The overall design is fairly simple, using flat faces and rounded corners. The simple design of the case was to make it suitable for 3D printing. The CAD model was 3D printed using the Ultimaker S5. The buttons are also designed and printed in a similar manner, with suitable symbols for each. Everything fits together easily, as the PCB and Nucleo microcontroller are screwed into place. The user can choose to look inside the device to see how everything connects together, gaining an appreciation for electronics. While our initial plans for the device were well thought out, we did face various challenges throughout the development which required creative solutions. With no existing footprint for the Nucleo board online, I manually created the necessary designs myself. This process was needed to complete the custom PCB. We had to devise our own mounting for the Nucleo board as we didn't have access to the STM32 chip on its own.
Another issue we faced was that our system didn't function after the initial solder was applied. To fix this, we undertook a lot of troubleshooting, eventually finishing with a working device.
In summary, our device features all the significant aspects described by the UK government's Electronics in Schools initiative. The games our consoles feature are suitable for the LCD display. These games are crafted not only to entertain but to educate, introducing Year 8 students to programming concepts in an interactive manner.
Coupled with a simple interface and controls, the console is designed to be straightforward and easy to use, making our system ideal for educational environments. We focused on creating a low-cost, high-value product. This approach makes it feasible for a child to have their own device without compromising on quality.
In conclusion, the Epsilon Zero is a fully functioning games console, which meets all of the requirements of an educational setting. We believe it can enhance the experience of students, inspiring them to engage with electronics in new ways.